Okay, so in this video, we're going to work on worksheet number 2. It says, I can determine the effects of A, H, and K. Now, when you do Desmos, and we're talking about the effects of A, H, and K, we're always comparing our new function to y equals x squared. Now, notice that y equals x squared is sitting right at 0, 0. And that this is the width of the parabola that we're always going to go by. So let's just start off by doing number 1. So when you have this type of problem, you want to always identify the A, H, and K. Now to do that, you need to remember the template of vertex form. The A is the number outside the parenthesis. The H is the opposite of what's inside parentheses. Remember, opposite when you're dealing with it. And then the K is the number on the outside. So you always got to do the opposite. So our A value is 0.35. Now notice that the A has 2 effects. So since it's positive, that's going to deal with one of them. And then we're going to look at the 0.35 as its own separate entity. Now, since it's positive, we know that it's going to face upward. So whenever A is positive, it's upward. Now that 0.35 actually makes the graph wider. Now because it's wider, that means that it is shrinking. If you put wider, that would be fine. Now, the H value is the opposite of what's inside the parenthesis. So it is going to be H equals a positive 2. And remember that the H is talking about your left or right movement. And since we're talking about the positive, we know that we're going to be moving right. And then you just write 2. So you want to be as specific as possible. Now our K value is exactly what you see inside the equation. So we saw a negative 6, and that is actually our up and down. Now since it's negative, it actually means it's going downward. So we're going to go down 6. Now as you get better with this, you're not going to need to graph it as much, but I recommend always checking the graph. So then we have x minus 2, quantity squared, minus 6. So then you can check. Your parent was at 0, 0, and now yours is at 2, negative 6. So if you gave directions, you would have to go right 2 and then down 6, which is exactly what we said. And notice that we also said the graph is facing upward, so our blue graph is facing upward, and it's wider than what was given as a parent function. Now I'm going to skip number 2 and I want to do number 3. Remember number 3, the A value is outside, the opposite of H, and then our K value. Now this is where students get kind of confused, because this negative sign is one of the effects, just like we did the positive up here. And then the second effect has to deal with the 0.05. Now together, that's why it's negative 0.05. But the negative tells us that it's going to be facing downward. The 0.05 means it's going to be wider, which is shrinking. Students have a very difficult time separating the negative from the actual decimal. So let's check to make sure that our graph is facing downward and that it's actually wider than our parent. So you can tell that it is slightly wider. Because if you look here, it's about 1.5 distance, and here's about 1.5 distance, which is wider than our 1. Now our h is the opposite, so I see positive 5, so I'm going to write negative 5. I see our k is just a positive 1. Now negative 5 on the x means left 5, and then a positive means up 1 for the k value. So if you look, if you start at the vertex 0, 0, you tell directions to go to your new vertex. We go 1, 2, 3, 4, 5 to the left, and then we're going to go up 1. Now, the graphing part is a little more difficult because how Desmos is set up. So you don't need the parent function anymore. But I recommend graphing the equation right away. The more you see the graph doing, the easier it's going to become. Now, we have an upside down graph, and we can tell that because our a is negative. So our h value, remember it's the opposite of our parentheses, is negative 3, and then our k value is negative 5. So I know that's negative 3, comma negative 5. Now if I could draw a vertical line down the middle of the graph, it would be at x equals negative 3. If you notice on Desmos, it can show it because it goes right through the vertex, right down the middle, cuts it in half, just like all of you have said. Now some of you want to do the opposite. If you make it x equals 3, is my purple line cutting the graph down the middle now? No, it's not. So if it's x equals negative 3, it cuts the graph down the middle. Now, since the graph is facing downward, that means this vertex right here, this ordered pair, is the top of the graph. The top of our graph means it's a maximum. Now, does my green graph touch the x-axis ever? No, it's actually underneath it. It will never touch it, so we call that no real solutions. The y-intercept. All you have to do is click where the green line, or whatever color it is, hits the y-axis, which in this case it's 0, negative 9.5. Domain is always going to be negative infinity to infinity. Since the graph is upside down, it starts at negative infinity and then goes to negative 5. Now, the hard part of the graph is the table. You want to hit this gear and then click table. This table that Desmos gives you are ordered pairs that go on the graph, but notice if you were to plot this, you would not get the full parabola. You would need the ordered pairs on this side. So what I recommend doing is just deleting all of these ordered pairs and starting fresh. How you do that? You take this vertex and you put it in the middle. So it's negative 3, negative 5. Now to make this table, you got to count backwards. So it would be negative 4 and negative 5. Now to make the bottom half of the table, you would count forwards. Negative 2, negative 1. So from there, you're going to make your table. So I typed it twice. So then we have negative 2 and then negative 1. So you just created a table, if you look, that's symmetrical. So there's 5 points. So then we have negative 7, negative 5.5, negative 5.5 again. So when we graph it, we go negative 5, negative 7 point, sorry, negative 7, negative 5, negative 7. Then we go negative 4, 5.5 in the negative, negative 3, 5, and then we can plot it. Now, if you notice, it really looks small, so we could plot another point, and we know that it's here. We know it's here. And you can extend it down. Your graph would be much better than mine because you're handwriting it. I'm on a tablet. So when you do a table, you really want to make sure that you're resetting it to make it look like the table that we want. So for example, number 8, if you write y equals 2 parentheses x minus 3 quantity squared plus 7. We got the gear and then the table. Once again, these are not symmetrical, 57, 39, 25, 15, 19. So we know the vertex is going to be 3, 7, because it's the h is 3, and then the k is 7. So if you put that in the middle right away, you can build your table around it. Count backwards, so 2, and then 1, and then count forward, 4, and then 5. Now, once you do that on the table, you delete all these numbers and make the table look like yours. All I'm doing is entering the numbers. And now on Desmos, they have graphable points. Now notice 15 is too high to graph on our piece of paper. Totally fine as long as you just kind of point the arrows up that way. So 2, 9, 3, 7, and then 4, 9. So it looks like a V, but remember you got to curve it, and then you can extend it upwards so it looks like a U shape. Since it is upright, since it is shooting towards the sky, this will be a minimum. Notice on Desmos, we can go back into the equation. Sorry if you already did this. And if you write x equals 3, notice how the red line goes right down the middle. So it's the x of your vertex. Once again, it does not cross the x-axis at all. So it's no real solution. Y-intercept. Now, I changed my screen. You couldn't see the y-intercept, but if you move your screen, and remember, if you're with your phone, it's even easier than that. It will tell you it is 0, 25. If you do not like using the zoom, you can go to table, and if it's not showing, you can just type in 0, because the y-intercept is when x equals 0. You get 25. Now our domain, always negative infinity to infinity. Now since our range, the graph is facing upwards, the lowest y value is 7. The highest y value is infinity.